All right, so welcome to week 5. Today we're going to be looking at absolute value functions. Okay, so we haven't looked at absolute value functions yet this year, but we have graph parabolas, and you'll see that the graphing form of a parabola and the graphing form of an absolute value function are very similar. All right, so this is right here, our first example. Y equals 2 times the absolute value of x minus 1 plus 4, okay? And this is, again, similar to graphing form of parabola or quadratic. And remember, the graphing form of the parabola is y equals a times x minus h quantity squared plus k. All right. Now, the graphing form of an absolute value function is going to look very much the same. Y equals a, and then the absolute value. Make sure to make your bar nice and long there so it doesn't look like a 1. X minus h, and then the closed absolute value plus k. And we have a vertex, just like in the parabola, h comma k. A tells you opening direction and how skinny or wide it is. But an important distinction is that the absolute value function, their graph is a V shape. Okay, so let's try this first example. Y equals 2 times absolute value of x minus 1 plus 4. Okay, so we know that the vertex of this is going to be the opposite of the number inside. So we have minus 1 or negative 1, comma, the number on the outside, which is 4. So the vertex is going to be 1, 4. Okay, this opens up. How do I know that? Because a is equal to 2. Opens up. And since this opens up, and the vertex is up here, we're not going to have any x-intercepts. We will have a y-intercept that we can solve for by making x equal to 0. So that's the last thing we need to do. So the y-intercept, we're just going to make x equal to 0. So we're going to have 2 times the absolute value of 0 minus 1 plus 4. Okay. That's equal to 2 times the absolute value of negative 1 plus 4. Absolute value of negative 1, remember the absolute value sign makes any number positive. So it's going to be 2 times 1 plus 4, which gives us 6. So the y-intercept is 6. So on the y-axis, it's going to cross right here. Okay, at the point 0,6. So this was, again, our vertex, 1, 4. Our y-intercept, 0,6. Now, just like a parabola, an absolute value function, the graph is symmetric. So if I go 1 to the left and 2 up, that means if I go 1 to the right, I'll also go 2 up. So this point is also on the graph. And remember, it is a V shape. So it's just going to be, we're going to have a point at the vertex. And that's our graph. Okay, let's look at a couple more examples here. Example number 1, y equals absolute value of x plus 3 minus 1. Okay, looks like a is equal to 1 here. So we know it's positive, so it opens up. Okay, the vertex is going to be the opposite of this number, positive 3. So negative 3, comma, negative 1. So let's find that on our graph. That's 3 to the left and 1 down. So it does look like we're going to have a couple of x-intercepts here because this opens up and the vertex is below the x-axis. So we will need to solve for those by making y equal to 0. So we're going to have 0 equals absolute value of x plus 3 minus 1. So we're going to add 1 to both sides first here. And we're going to have 1 equals absolute value of x plus 3. Okay, so the trick is with absolute value and solving for x is that you need to solve for x 2 times. So first, we just drop the sign and just pretend it's not there. So it's going to be x plus 3 equals 1. Or x plus 3, we drop the sign again, but then we just make the other side negative. So it was positive 1, so we just make it negative 1. And so then we're going to just subtract 3 from both sides here. We're going to have x equals negative 2 and x equals negative 4. So my 2 x-intercepts are going to be these 2 points, negative 2, comma 0, and negative 4, comma 0. Okay, so we'll mark those. So this again was our vertex, negative 3, comma negative 1. And you can see here, this is going to be one x-intercept, negative 4, comma 0, and the other one right here. Okay, so again, we need to solve for the y-intercept. And that's when we make x equal to 0. So it's going to be absolute value of 0 plus 3 minus 1. So it's going to be absolute value of 3 minus 1. Absolute value of 3 is just 3. So I have 3 minus 1, which is 2. So my y-intercept is the point 0, comma 2. So let's put that here on the graph, the y-intercept. And then if I go here, 3 to the right, I go up 3. So if I go 3 to the left, I also should be right here. And that gives us a nice collection of dots to draw our V. And make sure to include arrows at the end because the V extends in both directions. All right, let's look at example 2. Now, if you notice here in example 2, we have a negative sign in front of the absolute value. So the A value is negative, and so this V is going to be upside down. So A is -1, which means the V is opening down. Okay, so let's get the vertex. It is going to be +3, -1. Okay, so why do I always go for the opening direction and the vertex first? Because I don't want to put in the work to look for x-intercepts if they don't exist. In this case, again, they're not going to exist because this opens down and it's below the x-axis. So that just cuts down on our work. So there will always be a y-intercept that we need to find. So we're going to solve for that by making y or x equal to 0. So the y-intercept is going to be negative, and then in parentheses, or absolute value, 0, -3, -1. So we're going to have negative on the outside, -3 inside the absolute value. Okay, so think of this as like a negative in front of x squared. This is going to make this first part negative. Okay, so we're going to get a +3 from the absolute value, but then the negative in front is going to make it a -3. So -3 -1. And if we got +3 here, it wouldn't work out with what we anticipate our function looking like on the graph. And let's see, -3 -1 gives us -4. So we're going to have 0, -4. And that's right here. Vertex here, 3, -1. So to get another point in the V, we'll do the mirror point. I went 3 to the left, and I went 3 down. So if I go 3 to the right, I will also be at -4 for the y value. And now I can draw the upside down V, like so. Okay, so a little more practice here on the back of solving absolute value equations. Remember, we would do that in a graphing situation to find the x-intercepts. Okay, and as you saw in the front, there are a few steps to it. The first step is to isolate the absolute value. So get the whatever is inside the two bars by itself. Okay, and then you need to solve for x twice, like we did on the front. first time, you just drop the sign, the absolute value sign. And solve normally. And then the other you drop the absolute value sign. And then make other side negative. Okay, and why did I just say make other side negative and not just say change the sign? Because if you have something like this, the absolute value of x minus any number, we'll just say h, equals negative k. And this could be any negative number. Well, this has no solution. This can never be true, right? Because as long as you have that absolute value sign there, whatever here is going to be on the left-hand side, that's going to be a positive number. So this cannot happen. Okay? All right, so let's look at a couple examples here. So example number 1, we have 1 minus 8 times the absolute value of negative 2 plus r equals negative 31. Now, I see a negative number here, but I cannot say there's no solution until I isolate the absolute value first. And if I still have a negative number there, then I can say there's no solution. So we're going to first subtract 1 from both sides. And that is going to give us negative 8 times the absolute value of 2 plus r equals negative 32. Okay, number's still negative, but look what happens now when I divide both sides by negative 8. So on this side, I'm going to have absolute value of negative 2 plus r, so that's isolated by itself now. And then negative 32 divided by negative 8 gives me positive 4. So I am going to have solutions here, okay, because this is a positive number. So once we have this by itself, the absolute value, and I see a positive number, I can go ahead and solve for r, in this case twice. So we're going to drop the sign and just solve it like normal, or drop the sign again. And once I drop that sign, then now I can make this a negative 4. So I'm going to add 2 to both sides. And I get one solution for r is 6. add 2 to both sides over here. And I'm going to get r is -2. So those are my two solutions. Okay, let's look at one more here. Example 2. 1 plus 3 times the absolute value of v minus 2 is equal to 19. So first we're going to get rid of that 1 in front. And we'll have 3 times v minus 2 equals 18. And now we're going to divide both sides by 3. Notice when I divide this side by 3, nothing changes inside the absolute value sign. I'm just making this a form of 1. So I'm going to have absolute value of v minus 2 equals 18 divided by 3, which is 6. Not making my absolute value long enough. They look like 1s. Okay, so now we're going to drop the sign. V minus 2 equals 6, or v minus 2 equals -6. And then add 2 to both sides. We get v is equal to 8. Add 2 to both sides over here. V equals -4. And that's it. Next week, we're going to have 2 videos for the last week. There are no classes this week, at least for my class, because of AP testing. So just send me a chat, either Jupiter Grades or on Teams, if you need any assistance. All right, have a great week. Talk to you later.